All right, here we go. Section 1.6, the title of it is describing pairs of angles. I'm not only going to describe them, I'm going to work with them, play around with them, try to understand them. And this section is all about vocabulary and recognizing certain ways of naming pairs, only two at a time, pairs of angles. There's several of them, okay? So on page 48, which is where it really starts, the first couple of angle pairs we'll talk about are complementary and supplementary angles. You ever heard of those before?
Yes.
Some of you are nodding your head, which means you all have, you've just forgotten. Complementary. By the way, I think it's complementary. When you want to refer to complementary angles in your exercises or when we get doing proofs, you can abbreviate it comp with an angle symbol. A lot quicker than writing it out the way I did. Complementary angles are no more or no less than this. A pair. It has to be a pair. No, you can't have 3 or 4 or 5, you can't have just one. A pair of angles whose measure adds up to 90. Whose measures add up to 90. They may or may not to each other in some way. For example, might have an angle that looks like this, and another angle down here that looks like this. And if this angle, whatever its measure is, and this angle add up to 90, this is a complementary pair. For example, if I had this 36, 54. If I tell you this is 36 degrees and I tell you this is 54 degrees, whether it is or not, but I tell you that it is, then you can name these as a complementary pair. Most often, however, you will see a complementary pair that is connected. And this is also a complementary pair, but they don't have to be. If we are told that this is a right angle with a box and you draw another angle coming out like this, you're for sure, absolutely certain, without even knowing the measures of both of these, you're certain that they are a complementary pair because this angle added to this one has to add up to 90 without knowing the measures of them. That make sense to you? And it can only be a pair. Don't draw a third one. Now, if you draw a third one, you haven't got a pair anymore. You haven't got a complementary anything. Complementary angles always come in pairs and only pairs. Supplementary angles. And I'm going to abbreviate this. I'm not going to write it all out. Supplementary angles can be abbreviated this way, SUPP with an angle symbol. And supplementary angles are a pair, must be a pair of angles that add up to 180. They also do not have to be connected. Like I might have an angle like this, and another angle down here like this. And if I tell you this is 150, and this is 30, for example, they are a supplementary pair because 150 plus 30 is 180. But most often they are connected in the same way those are. Like this. If you've got a vertex right there, this is a straight angle, right? Remember the name of this? This is a straight angle. If I draw an angle coming out like this, you can be certain that that is a supplementary pair of angles. Because the straight line indicates that together they make 180, and that's what's required. Everybody okay with that? Okay, so those are your two angle pairs, and here's how you can remember the difference. Remember which one's which. C. The letter C comes before the letter S in the alphabet, right? Way before. Well, guess what? 90 comes before 180 when you're counting. The first letter goes with the first number. The second letter goes with the second number. So that's why you can remember complementary and supplementary and what they do. Complementary goes with 90. Okay? All right. The next kind of angle pair that I want to talk about are called adjacent angles. And they are angles that are right next to each other. They share a common side in the middle, like this. If I put this out like this, these are adjacent. if you want to abbreviate that, you can abbreviate it ADJ, angle symbol. Adjacent angles is also a pair of angles. I only have one angle here. It's a pair of angles such that they share a common side. So this angle 1 and this angle 2 are adjacent angles. Adjacent means right next to. Yeah.
So if they like bisect, is that?
That's an additional property to it. That's not necessary for angles to be adjacent. Angles can be adjacent if they share a common side in the middle. See, angle 2 shares this side, but angle 1 also has that as one of its sides. And they have to share a common vertex too. I mean, you can't have something like this. These are not adjacent. If you come out like this and you have another angle coming out like that, those are not adjacent. You have to share the same vertex. Okay, so 1 and 2 are a pair of adjacent angles. I need to backtrack here and show you these angles are adjacent and complementary. Because of this symbol here, we know they're also complementary, but they're adjacent because they're right next to each other. These angles are adjacent to each other because they share this side, but together they make a straight line on the bottom. The other two sides make opposite rays, making these two not only adjacent, but supplementary. This pair is not adjacent, obviously, and neither is this pair, but they're still complementary. You getting the gist here? Getting the idea? I hope. Okay. Take a look at example 1 with me. It says, in the figure, name a pair of complementary angles and a pair of supplementary angles and a pair of adjacent angles. Notice that they haven't got the angles numbered. If you want to, and it takes a little while, but if you want to draw these pictures on your paper and number the little angles instead of calling by 3 letters every time, you're welcome to do that. I'm not going to because the book does. Now, you can also just leave it in the book and use 3 letters to name every angle. So this is what we're tasked to do. Name a pair of complementary angles. That's the first thing. Can you find a pair of complementary angles? And if so, raise your hand and tell me what you think they are. Complementary angles in this picture. Yes.
Angles CAB and RST.
How do you know they're complementary?
Because 37 plus 53 is 9.
Perfect. Do you understand all that? That's awesome. That was a really great way of saying that. Okay. Supplementary angles. Can anybody name a pair of supplementaries? CAD and RST. And why do you believe that? Okay, she's not talking very loud, but it's because 127 plus 53 is 180. That makes them supplementary. We're also supposed to name a pair of adjacent angles. Go ahead.
CAB and CAD.
CAB and CAD, do you agree? They're right next door to each other, sharing the common side AC and the common vertex A. Yeah? Pretty good? Not too bad. Okay. Let's take a look at example 2. We're still messing around with these ones we've just learned. It says in example 2, they're not going to give you a picture, and it says angle 1 is a complement of 2, and angle 1 is 62. So how big is 2? I heard it. 28. How come? How did you figure it out? Sorry?
90 minus 60.
There you go. And why did you choose 90?
Because complement is
90. That's good. Excellent. Okay. Angle 3 is a supplement of angle 4. Angle 4 is 47. What's 3? 133. And how do you know that? And why 180? Yeah, because it's a supplement. Everybody good with that? Not very hard, right? Okay, good. Moving on. Let's take a look at example 3. This is kind of a silly example, I think. But anyway, take a look at it. They've got a diagram there. It says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. In other words, the rack on this thing that holds the net is shaped like this. Got the net right here. We're looking at it from a side view of this. Here's the net coming down like this. There's a little curly thing right here, and then here's the frame coming out like this. Well, if we don't make this curly but sharp, and we extend this so that the ground where the rack, the bottom of the rack's laying along with the ground out here, it forms a pair of supplementary angles that are adjacent. Do you agree? Okay. And you'll notice that, I don't know why anyone would give it in terms of X, but they did. So if we look at our diagram and write down what they're trying to tell us. They're trying to say that this angle right here is x plus 2. And this angle over here, believe it or not, that's what they're trying to tell you, is 4x plus 8. Now, here's the temptation for people who are not really paying attention. The temptation is every time you get two things written in terms of x, they are equal to each other. And that's how you write the equation. That would be false in this case. This is definitely an acute angle. This is definitely obtuse. They can't possibly be equal to each other. But there is something we do know about them. They when you add them, they equal 180. So the equation on this one is 4x plus 8 plus, not equals, plus the x plus 2. They form a supplementary set of angles because these are opposite rays and these are adjacent to each other. So they got to add up to 180, and that's what we write. And then the geometry is over. Then we apply our algebra skills. 4x and x is 5x. 8 and 2 is 10. 10 from 180 is 170. 5 goes into 170. 35 times, I think. Is that right? 34 times. 34 times, right. 34. Again, we're not done. That is not what the question asked. In fact, I didn't even read what the question asked. I got to go back and read to you what we're trying to do. It says, this frame, this kickback screen forms a frame. We already talked about all of that. We labeled everything. We got everything written down. And it says, find the measure of BCE. BCE. That's this one. So we got to find the measure of this one. That's the big one, the BCE. And they also want us to find ECD. That's the little one. Which one would be easier to find? The small one. It's going to be 36, right? It'll probably be easier to find the big one by taking 36 from 180, but you could also take 4 times 34 and add 8. You get the same thing. But I think it would be easier to solve the little one and get a 36 and then subtract 36 from 180, which is 1 what?
44.
Okay, those are the answers to the question. Not this. This is just the answer to the algebra. You got to go back and answer the question with it. Okay, any questions so far? Okay, another set of types of angles. So I'm going to erase all of this, and we're going to get another couple of pairs that are related to one another. Okay, the next one is called a linear pair and vertical angles. A linear pair. You're going to get confused, probably a little bit. Do you remember when I said that this, if we draw this like this and we put a point right there and draw an angle out, we said this was a supplementary pair? They are supplementary. But when we're not referring to the measure, supplementary refers to the fact that they have to 180. That's the big thing about the word supplementary. I want to just talk about the picture. When you have this situation where you have two angles that are adjacent and they form a straight line with the other two sides, often referred to as a linear pair. Linear here means that's the root word of linear is line, a linear pair of angles when we want to just talk about how they're oriented to each other, not about their degree sizes. We know they must add up to 180. That's true. But when we want to focus on the picture itself and the fact that we had a straight line and an angle coming off of it, these two angles, 1 and 2 now, are a linear pair, and you may abbreviate like this. 1 and 2 are a linear pair. They're also supplementary in measure, but if we're not focused on the measure, only how they're oriented to each other, it's a linear pair. Okay? When you have two lines which cross each other, here's a line coming out of space somewhere on this plane, here's another line. As soon as you have two lines which cross like this, you immediately have 4 angles. The ones that are opposite of each other, like 2 and 4, they are called a vertical pair. But in this case, the word vertical does not mean up and down. Vertical does not mean this. In this case, vertical means opposite in the crossing of two lines. So 2 and 4 are a vertical pair, but 1 and 3 are also a vertical pair. Not a horizontal pair, a vertical pair. They are only vertical pairs, and they are or angles that are opposite one another when two lines cross. So we have two vertical pairs here, 2 and 4, and 1 and 3, vertical pairs. Okay, recognizing when you see it, I better write that up there. And you can abbreviate this vert pair, vert PR. Okay, look at example 4. Like the diagram, all we've got is a bunch of angle numbers. We don't even have any letters at all. So you gotta look at example 4 to see what we're talking about. In example 4, it says identify all the linear pairs. Let's do that first. Identify all the linear pairs. Can you even see any linear pairs? It's like this. It's a situation like this where there's only 2 angles, and together they're the sides that they don't share form a straight line. Go ahead.
Angle 4 and 5.
4 and 5. Is that what you said? Yep, I agree with that. You see the 4 and 5 together form a linear pair? The line part of it is this right here. The linear part. What are we on? 1, 6. I'll get there. Hang on, I lost it. Yeah. Okay, so I'm gonna keep losing the page. The linear part is this line right here. You see that they're taking off down below. It doesn't always have to go above. They're taking off down below, making angle 4 and angle 5 when you draw that extra angle, and they must be a linear pair because the other side is a straight line. See what I'm saying? Can you name it? Are there any others?
1 and 2.
1 and 2?
1 and 3.
1 and 3.
Nope. 1 and 3 are both acute.
Oh.
3 and 2.
3 and 2 are both acute. Well, one's obtuse, one's obtuse, but they are acute. They don't form a linear pair.
1 and 4.
1 and 4 form a linear pair. You can't get 2, 3, or 5 to participate in this part of the discussion because it takes 3 of them to sit on a straight line. We're talking pairs here. You know what I mean?
5.
So 1 and 4 are a linear pair, 4 and 5 are a linear pair. Those are the only ones. Sorry, 5 gets to participate. 2 and 3 don't. Then they want us to name all vertical pairs of angles. That's when 2 lines cross and form opposite angles. Can anybody name a vertical pair of angles? You said 1 and what? 1 and 5. I'll agree. 1 and 5 is a vertical pair.
Is 1 and 3 one? No, that's it. 2 and 4. 2 and 3.
2 and 4 are not vertical because 2 has that, it's got that line coming. You see how 4 is really quite obtuse? 4 is really obtuse. 2 is not. 2 could almost be a right angle. 2 and 4 don't work. But the combination 2, 3, if you put 2 and 3 together as an angle, that would be vertical to 4. But you're not allowed to do that. Not without some letters to name some angles. The only vertical pair here is 1 and 5. That's it. So it's kind of tricky. You gotta, and it's gonna get this way more and more and more. What you gotta do is be able to look at a diagram and throw out the irrelevant stuff. You gotta be able to get that out of your sight. You gotta get out of your line of sight and see. The only 2 lines that actually cross in this picture, the one we were just talking about, are the one that goes up like this and the one that's flat like this. Those are the only 2 crossing lines. So those are the only ones that can form a vertical pair. So it's only 1 and 5 because on the other side of 4, there's 2 angles. I know, it's kind of crazy. It takes some practice. All right, now example 5, I want you to understand that in example 5, they've got, in the solution, they've got a diagram drawn. You will not get that. So let's pretend that we didn't see the diagram in example 5 and we're only looking at the words. Just the words, it says, 2 angles form a linear pair. Okay, so we're getting in our mind an idea of what that means. They form a linear pair. The measure of one of the angles is 5 times the measure of the other angle. So one's really big and one's really small. So here's our linear pair. We start with a line. Here's going to be my vertex. One of them is going to be 5 times the size of the other. So I'm going to draw it like this. So that's really big and pretty small. One is 5 times the other. This would be the other. Because if this is the 5 timeser, that's the big guy. This one is 5 times the size of this one. But what is this one? X. So this one will be 5x. See? Don't know either of the angles. We just know this is they're how they're related to each other. We also know because linear pairs are also supplementary. Now we're jumping that little thing over there. This is also a supplementary pair, which means that one angle added to the other angle must equal 180. That's our equation here. You see what I'm saying? You guys understand all that? Because all you got was words. Linear pair, one angle's 5 times the other, so you draw a linear pair, make them so that one looks like it's 5 times the other, so you can it matches what your thinking is. And then you say, okay, this one's 5 times this one, but what's this one? Oh, I don't know, so I'll call it x. Then this is 5x, and they must add it to 180. That's a lot of linkage. After that, the algebra is not very hard. If I could just do it. So if x is 30, then how big's the big guy?
150.
So it's going to be 150 and 30 for your answer. Because x was actually one of the angles, and so that is one of the answers, but you got to plug it back up here to find the other one. So we get, that looks like a semicolon. It's 150 degrees, comma 30 degrees. Are the sizes of those angles in that situation. Lot of links you've got to go through. Linear pair, draw it. Make one really small and one really big. What's the small one? I don't know. Call it x. This is 5x. Because they're a linear pair and supplementary, they must add up to 180. Solve it. Now what? I've got to take it times 5 and answer the other question. It's a lot of linkage in your brain. One more thing. Well, 2 more things that I want to go through the monitoring progress with you on this to make sure you understand what's going on. The top of page 51, monitoring progress. You have to be looking at the diagram, and I'm going to read the words. You look at the diagram and see if you can start to formulate an answer. That diagram there says, do any of the numbered angles in the figure form a linear pair? Any line that you choose to let your eyes settle on are always, I don't care what line you're on, are always split up into 3 angles at the minimum. 6 if you look on both sides of it. You know what I mean? And pair means 2, so the answer is no. Explain your reasoning. Every line has 3 angles or more on it. And we're talking pairs. That's what you would say. Number 7 says, in this same picture, it says, the measure of an angle is twice the measure of its, no, we're not referring to that diagram anymore. That diagram's done. Now we have to translate. This is going to be rough. It's going to be kind of rough. There's something I want to do to help you answer 7 and 8 first. We're going to come back to 7 and 8. Something I forgot to tell you, show you, or whatever. Develop for you. So I want to show you this and see, after I'm done with this, if I can make these problems we're about to do a little bit easier. So I'm going to draw a table here. And I'm going to have the word complementary here and the word supplementary here. You might want to have your calculators out if you're not very good at arithmetic. I'll put the angle here. Now I'm going to put an angle here, and I want you to tell me it's complement and supplement. Okay? So if I put on here, I'll start out kind of easy. If I put on here 30 degrees, what is 30's complement? 60. How do you know? Because 30 plus 60 is 90. Or, did anybody do a subtraction? Did you do, what subtraction did you do?
90 minus 50.
Good. What's 30's supplement? This is the angle. What's its supplement?
150.
How do you know? 180 minus 30 is 150. Yeah? Okay. Let's do 45. What's the complement? 45. Because 90 minus 45 is 45. That's how I want you to answer it. It's a subtraction thing. What's the supplement? 135 because? Excellent. Okay, let's try this one. 70. What's this? 20. What's this? 110. I don't know if I heard it. I was waiting to hear it very definitively here. Okay, so this one I'm going to say is 115. There is none. If you pass 90 with one of your angles, you can't have a complement to it. We're already past it. So what's its supplement? 65. Okay, let's do a couple more of these. Let's do 89. What's this one? 1. What's this one? 91. They're pretty close to being Okay, let's do 4. What's this one? 86. And this one? 170 what? 6. Okay, let's do this one.
9.
What is its supplement? I'm sorry, what is its complement?
9. 4. Why?
Assume that this is less than 90. We're not gonna go there. If this is the angle, what is its complement?
90 minus x.
Perfect. 90 minus x. We don't know what it is, but if we did know this, we'd take 90 minus it to get its complement. And so we write down what we would do if we could. Do you understand that? So this next one's a little easier now that you see this one. What's this one? 180 minus x. Now, here's what I want to talk to you about is the words that you're going to see in some of these exercises here. If it says, well, I'm just going to write it right here. This right here is what you will write on your paper. If you run into the words, its complement. And this is what you will write, this actual expression right here. If it says its supplement. If you run into that, what is it? This is it. If this is its complement. Does that make any sense? This is it. This is it. This guy's over here. This is his name is it. This is his complement. Right here. That's what you will write. This is its supplement. When you don't know what it is, and it has to involve x, these are how we would figure it out. And that's what the table tells us, what we did every time is subtraction. So watch for these phrases and translate them this way. So now let's do number 7. It says, the measure of an angle is twice the measure of its complement. The measure of an angle, that's it. The measure of an angle, I'm going to erase this up here. The measure of an angle is, do you guys know your verbs of be? I'm talking English now. Am, is, are, was, were, be, being, been, have, has, had. Didn't your 8th grade teacher teach you that?
No.
Mine did, and I've never forgotten. I'll take it to my grave. Am, is, are, was, were, be, being, been, have, has, had. Those are all verbs of be. And the main verb of be's that they use in these books, these math books, is or was. And when you run into that, trying to translate words into an equation, is means equals. It's the verb. Wherever the verb is, that's where you jump from one idea, verb, other idea. And the verb is usually is. So let me read again. So it says, the measure of an angle is. What's the measure of the angle? That is twice the measure of its complement. So it's going to be 2 times something, and it's going to be 2 times the measure of its complement. But the measure of its complement involves 2 terms. So it's got to be in parentheses because you're going to take 2 times in that entire phrase. Its complement. So let's look at the translation again now that you know some things. It says, the measure of an angle, and then you run into the words this. So you go back and say, the measure of an angle. What's the measure of what angle? Oh, yeah, that's it. Measure of an angle is twice its supplement. And its supplement has 2 terms, so you got to have parentheses because twice something with 2 terms in it's got to be parenthesized. Everybody clear on this translation? Now we solve it by distributing. Adding this over to here, so everything's kept positive. So if x is 60, then its complement is 30. So the answer is 60 and 30. Here's the translation. Once you've translated it, then it's all algebra, and then you got to do something with that at the end. If it is 60, then its complement is 30, and you list both angles. That make sense? Try number 8. 2 angles form a linear pair. Oh, talking complementary. The measure of one angle is 1.5 times the measure of the other angle. I would, in this case, because they talk to you about a picture, I would draw that linear pair. I'll go ahead and use this one, not as an example, but the actual thing. And it says 2 angles form a linear pair. One of the angles is 1.5 times the other. Well, what's the other? The other is x. This one's 1.5 times it. You okay with that?
Mm-hmm.
And because linear pairs are supplementary, we have this equation. And a 1.5 x's plus a whole x is 2.5 x's, so we're collecting like terms. And then if I divide, I don't know what that is. So I'm gonna take 180 divided by 2.5.
72.
So one of the angles is 72, what's the other one? Okay. So sometimes they offer you a picture and you should draw the picture and put the angles on there the way they go and then see if you can figure it out. Sometimes they give you a phrase to translate. We never drew a picture for this. But we translated the words. Are we good or not? Okay, this last bit of discussion. I cannot tell you how important it is to your success or failure in here to, on this concept summary on the bottom of page 51, how important this stuff is, this part. Because you'll make mistakes if you don't understand what I'm telling you. So if you don't understand what I'm saying, and I'm talking too fast, if your mind wanders, please tell me. It doesn't seem like it's that big of a deal, but boy, it sure will be. There's some things that you can assume from a picture by just looking at the picture, and there's some you cannot. And that's what this concept summary is about. So, off the bottom, and then near most of the page, on page 51, where it says concept summary, I want you to look at that picture. And the author says this: there are some things you can conclude from the diagram. I call it a picture. There's some things that you can just look at it and know is true, and some that you can't. You need to figure out which one it is. For example, here are some things that you can say about this picture right here. Don't look at the ones you can't yet. But you can say, for example, that A, D, E, C, and B are all collinear. I'm sorry, coplanar. How do we know that? Because they're all in the page, the plane of my page. They're all written in that plane. They are coplanar. You can also absolutely determine that they are, as a group, not collinear. You could conclude that A, B, and C are collinear by just looking at the picture. You could conclude that A, B, and D are not collinear. You could decide that B is between A and C, because B is on A and C and in between the two. So you can conclude that B is between. That's an actual geometric word, between. B is between A and C. E is not between A and C. You can conclude that. You can conclude that ray BA, BD, BE, and BC all start at B. They all have the same start point. You can also look at the picture and decide that angle DBE and angle EBC are adjacent. You could conclude that angle ABD and DBC are adjacent. You can also conclude that if you really wanted to say it, that point E, just the point, not the ray that's on, but just point E is on the interior of angle DBC. Here's things you cannot say from the way the picture is drawn. You cannot say, for example, that segment AB equals segment BC. They certainly look like it, but look like it does not matter. There is no indication that they are the same length. You cannot conclude it even if it looks like it. Here's another thing you cannot conclude about that picture. Find angle DBE. DBE, do you see it? That is not necessarily equal to EBC. Even if you took a protractor and measured it and it looked like the protractor measured them the same, you may not conclude that they are the same just because they look like they are the same. You have to be told. You have to have some other indication that they are equal. So you cannot conclude that by looking at that original picture. You also cannot conclude that ABD, everybody find ABD, you cannot conclude that that is a right angle. Even if it looks for all the world like it is. If it does not have a box down there where the two are formed, that little box that I've been drawing all day, you may not conclude that. And then he goes on to say the things that you cannot conclude would need these additional markers. Now look down at the picture at the bottom because these have the appropriate marks to let you conclude those things. For example, you see the two slashes that are there, one of them on DBE and EBC. See the slash marks in the angles? Not slashes, but the bands. Because they both have a single band, you can now say that they are equal because the markings indicate that they are. And guess what? Even if they look equal, but they both have a band in them, you must assume that they are, now that they're marked. Also, to conclude that AB, segment AB and BC are equal, see the two slash marks on those segments? That indicates they are equal. Now you can say they are, not without that information. And see the box in the corner? That indicates you've got a perpendicular. Without it, you may not conclude it, even if it looks like it. You understand what I'm saying? Lots of things you can, quite a few things you cannot. So if you're asking yourself, it looks like it's a right angle. If it doesn't have the box, you may not assume it, even if it looks like it. So be careful. Then you turn the page, and now we get out of this daunting business of this. It's really important. There's your exercises. It won't be that bad, and we will discuss those things again, those things you can conclude and those that you cannot, as they arise. Okay, here's the assignment. 29 problems. It's quite a lot, but most of the time you just have to look at something, maybe add a couple of numbers or something. 2 through 7. Is everybody ready to write? You can hear some buzzing around it. 2 through 7, 9 through 15, odd. 16 to 22, 25, 32 to 41, all of them, and 46. Okay, I'll leave my book up here so you can check if there's any evens or whatever, and you may work together, but please learn this stuff because you have to take the test by yourself.
Thank you.